Okay, Assalamualaikum and hi everyone. Alright, so today we are going to discuss on the last subtopic for this chapter, that is 1.3 factors affecting reaction rate part 1. Okay, right, so siapa-siapa yang belum subscribe channel saya, silalah berbuat demikian supaya awak akan dapat update paling cepat daripada orang lain lah. Okay. Right, so what are the things that you are going to learn for this subtopic? Okay, for part 1, you are going to learn the effect of uh, the following factor on the reaction rate in terms of concentration of pressure, temperature, catalyst, and particle size. Right, so there are 5 factors that affect the reaction rate. First is in terms of concentration, pressure, temperature, catalyst, and particle size. Right, so before we move, so we have to recap back what we have already learned during previous lesson. So in this topic, you will always use the word effective collision. Okay, so what is the meaning by effective collision? So there are 2 requirements for the effective collision to occur. So still remember, first is about minimum energy. So we refer to the activation energy, EA. That is minimum amount of energy required to start or to initiate a chemical reaction. Okay, so molecule must have this minimum energy for the reaction to occur. Okay, second requirement is correct orientation. So each molecule must collide, but in correct orientation or right orientation, okay, in order to form effective collision, and at the end will form products. Okay, so remember 2 requirements for effective collision: minimum energy, okay, and also correct orientation. Right, so we move to the first factor, that is concentration. So if the concentration of the reactant increase, so the number of particles per unit volume is increased. Okay, right. So this will affect the frequency. Frequency ni kekerapan. Frequency of collision increase, and therefore frequency of effective collision also increase. So dia ada perbezaan antara 2 point ni. Okay, frequency of collision increase maksudnya molekul tu sekadar melanggar saja, tak semestinya effective collision. Okay, so dalam banyak-banyak pelanggaran tu, so dia akan produce lebih banyak effective collision. Ada di antara pelanggaran tu akan menghasilkan effective collision. Okay, so as the result, the rate of reaction increase. So we can conclude that the rate of reaction is directly proportional to the concentration of the reactant. However, it is depending on its rate order. Okay, for example, like 0 order, we know that rate is equals to K, concentration of reactant power of 0. So therefore we get rate equals to K. So therefore if we increase the concentration of the reactant, the rate remain constant. Okay, but for the first order and the second order, rate is depending on the concentration of the reactant. As the concentration reactant increase, the rate reaction also increase. Okay, alright. So reaction rate is directly proportional to the concentration of the reactant for the first order and the second order only. 0 order is excluded. Okay. Alright, so in terms of pressure, so when pressure is applied, volume decreases. Okay, so we already know that. What will happen next? Number of molecule per unit volume increases. Okay, alright, so next, frequency of collision increase, and also frequency of effective collision also increase, and therefore the rate of reaction increases. Okay, right. So therefore we can conclude that the reaction rate is directly proportional to the pressure. So as the pressure decrease, the rate of reaction also decrease. As the pressure increase, the rate of reaction also increase. So we have refer for both factor. So kalau awak tengok perasan, 3 point yang terakhir ni adalah sama. Okay, 1, 2, 3 sama. Jadi kena ingat point pertama dengan point yang kedua sahaja yang you kena ingat. Okay. Alright, we move to the factor number 3, that is refer to the temperature. Right, so the higher the temperature, the kinetic energy of molecule increases. So this is because the molecule will absorb the energy. Right, so more molecule will have kinetic energy greater or equal than the activation energy. The activation energy is referred to the minimum energy required to start the reaction. So therefore, more molecule will have higher equal to the activation energy. So the next point is the same. Frequency of collision increase, frequency of effective collision also increase, and therefore the rate of reaction increases. So in conclusion, reaction rate is directly proportional to the temperature. Okay, we can see in this animation, when the temperature increase, the molecule will absorb the energy and therefore its kinetic energy will increase, and hence the rate of reaction will increase. Alright, so in terms of temperature, you have to know about this Maxwell-Boltzmann distribution curve. Right, so kinetic energy distribute for a reaction mixture at 2 different temperature. If we compare the kinetic energy for the reaction in 2 different temperature. So what you should know about this Maxwell-Boltzmann distribution, alright? Okay, so there are 2 temperature, that is T1 and T2. Okay, T1 is lower temperature than T2. For example, let's say lah T1 here is 80 degree and T2 here is 100 degree. Okay. Alright, so the curve under the region under the curve here, for example like T1 is it refer to the total number of molecule at T1. Okay, and then the region under the curve T2 is referred to the total number of molecule react at T2. So in both condition, the total number of molecule is equal. Okay. Alright, so and then the shaded area. What is the meaning by the shaded area? Okay, the shaded area represent the number of molecules possessing kinetic energy equal or greater than activation energy. So here is the activation energy, which refer to the minimum energy required to initiate the reaction. Okay, right. So we can see that for region T1, here is the region T1 that is lower temperature. Okay, the shaded area here is represent the number of molecule at T1 that possess kinetic energy equal, this is equal or greater than EA. Alright. So and then the shaded area for T2, here is the shaded area for T2. Okay. Which represent the number of molecule that possess the kinetic energy equal or greater than the EA. So we can clearly see that at T equal to T2, which higher temperature, more molecule would have higher more molecule will have kinetic energy equal or greater than EA when compared to the molecule at T1. So we can conclude that at higher temperature, which means T2, more molecule will have higher kinetic energy than at lower temperature. Right, so when temperature increase, so the number of molecule with kinetic energy equal or greater than EA will increase. So therefore, this region, okay, shaded area at T2. Okay, what would happen next? The frequency of collision increases, and therefore the frequency of effective collision also increase, and the rate of reaction increase. So these are all the points that you have to include in your explanation, right? Okay. Alright, next we move to particle size. The smaller the size of reactant particle, the greater the total surface area exposed for reaction. And frequency of collision increases, frequency of effective collision also increase, and therefore the rate of reaction will increase. So we can conclude that reaction rate is inversely proportional to the particle size. Okay, as the particle size getting smaller, okay, getting smaller, alright, so its surface area become larger, and therefore the rate of reaction will increase. Okay, so these are the example. So in our daily life, for example, like awak ambil gula. So kita ada gula yang serbuk tu kan, gula halus dengan gula batu. So kalau kita dissolve dalam air, let's say hot water, so we can see the reaction untuk kita larutkan gula halus, dia akan ambil masa yang lebih singkat berbanding kita ambil gula batu. Okay, kita larutkan, dia akan ambil masa yang lama untuk dissolve. Okay, so the smaller the size of the particle, the greater the total surface area of the reaction, the greater the surface area exposed for reaction, and therefore the rate of reaction increase. Alright, in terms of catalyst. Alright, so first of all, we have to define what is the meaning by catalyst. A catalyst is a substance that provides an alternative pathway with a lower activation energy to increase the rate of chemical reaction without itself being consumed. Ni dia punya definition. Dia kena ingat, dia kena hafal ya. Alright, so next. Okay, so more number of particles with energy equal or greater than the lowered EA. So function catalyst ni dia akan merendahkan activation energy supaya lebih banyak molekul boleh dapat minimum kinetic energy. Sama dengan EA ataupun lebih tinggi daripada EA. Right, so the next point is the same. Frequency of collision increase, frequency of effective collision also increase, and therefore the rate of reaction increase. So kalau awak dah tengok kelima-lima faktor tu, awak boleh perasan lah. The 3 point yang terakhir ni dia sama. Jadi kena ingat point pertama dengan point yang kedua sahaja untuk topik ni ya. Alright, so in conclusion, catalyst increase the rate of reaction. So for example, let's say I have this reaction. Okay, hydrogen peroxide decomposed into H2O and oxygen gas. So without catalyst, we can compare the bubble of oxygen gas release is very small amount. This is without catalyst. Ini kalau kita tengok dari in terms of observation dia lah kan. Okay, but when we add MnO2, that is refer to the catalyst. Okay, right, so we can see a vigorous reaction will occur. So nampak bubble of oxygen gas release lebih banyak, lebih cepat berbanding dengan yang tanpa ada catalyst. So therefore, kita boleh buat conclusion, catalyst increase the rate of reaction. Okay, kalau kita nak lukis in terms of energy profile diagram, right? So kita boleh nampak jelas kat sini. So this is endothermic reaction. So when we add catalyst, the EA here is at this region ni. Ni EA with catalyst. So dia lebih rendah berbanding EA without catalyst. Okay. So which means lebih banyak molekul yang boleh achieve EA. Okay. Sebab EA dia dah jadi rendah. Okay. Alright, so for the endothermic reaction, so this is the EA with catalyst, which is lower than the EA without catalyst. Okay. Okay, settle. Alright, so that's all for today. Thank you, and we will see again in what factor affecting reaction rate part 2. Okay, that's all. Thank you, and Assalamualaikum.